And I think I should be live. I know people will be joining in here shortly. As you join in, say hello in the chat and maybe where you're watching from. And if you want to throw in a little bit more information, I'd love to hear about what you're building with machine learning, or maybe why you're interested in, um, building AI pipelines or ML pipelines like we're going to see today. Say hello in the chat real quick too. So again, yep, cool. I already see some people here. Again, it's way more fun for me, but also probably for you. I think if you say hello in the chat, and feel free to talk in there as we go through the workshop. I'll be looking at the chat and answering questions as we go. If I don't get to any, hopefully I'll get to it at the end. And if it gets really busy in there, I might miss it. And again, you can feel free to bring it up later too. I'll stay around and answer some questions after the workshop as well. And we'll get going here in a couple minutes. We're still 1 minute earlier than the start time right now, so I know people will be rolling in. And again, while that's happening, say hello in the chat. Also, if you plan on following along, the only account that will probably take a tiny bit of time to sign up, and not the actual sign up process, but the approval process, is the Union account. We're going to be running our workflow in this tool today. We'll talk more about it shortly. It's a hosted version of an open source tool. So all the stuff we're going to see today, you could implement in the open source as well. But setting up the open source takes a little bit of extra time and environments. There's a lot of environment variables. So to make it really easy for the workshop today, there's a hosted version you can sign up for. And then we'll be able to run our workflows in there. And we'll be writing them in Python using scikit-learn. Again, we'll talk more about all the stuff we're going to cover here shortly as people roll in. But again, I already see a few people here. So if you want to say hello in the chat, it's always appreciated. And like I mentioned, we'll get rolling or started here in a few minutes. We're going to go through some slides, but then a lot of this will also be a hands-on part. So if you want to follow along and run some code, I hope you will. Otherwise, you're also free to watch me run the code, and I'll kind of explain what's going on as we go. Somebody said that they're a computer science student at California State, and they're in the East Bay and attending the workshop for credit. Awesome. I didn't know you could get credit for it. And would like to learn and gain some practical experience about ML pipelines. Awesome. Well, this is going to be hopefully a really good introduction to ML pipelines. If you've never built one before, this is a great place to start. And we're going to use some specific tools today, but just keep in mind the concepts you're going to learn. And if you use a different tool later, you'll hopefully kind of have a good understanding maybe what to look for when selecting a tool. And while we're waiting for people to join in, and I'm seeing people join in, so again, feel free to say hello in the chat, where you're watching from, maybe, why you're here at this workshop. And we'll get going here in maybe like 2 more minutes or so. Then we'll start going through some slides and then get to the hands-on part. So one of the questions too is, what are the use cases and applications of machine learning pipelines? Well, as we go through some of the slides, I think you'll see some of those use cases. I'm not sure if maybe you've trained a machine learning model, but kind of putting one in production and doing it at scale, like in a big company, is pretty different than like training a model in a Jupyter notebook and then having it live there. There's a lot of stuff that goes into scaling that and making them more reliable. And again, we'll touch on all these as we go in. I'm seeing more people joining now. Welcome everyone. Say hello in the chat. We're just waiting for some more people to join, and then we'll get going here. We're going to go through some slides, and then we'll go through the hands-on exercise where you can actually build a pipeline. And I shared this link before. Also, all the links are in the description. So also, if you're watching the recording of this, you can go to the description and find all the links here. The thing that you might want to do right now, if you want to follow along, and again, I'll call this out later too, is sign up for a free Union account. There's no card or anything required for it. It can take 3 to 5 minutes to onboard you. And a quick note on that is, if your GitHub account is older than a month, it might take longer. We've had to implement some practices in there to, basically stop bots onboarding. So hopefully someone can fill that out, or some people can fill that out and let me know. Again, it can take a few minutes to get approved. It'll say join a waitlist, hit join now. And again, if you have a newer GitHub, it might take longer, but we can get you approved later. If it doesn't happen during this workshop, just message me on Slack or LinkedIn or something like that, and I'll share that information later as we go. But hopefully, if you have a GitHub account and you've had it for a little while, the onboarding should only take 3 to 5 minutes. And all right, so I'm going to go ahead and run through some of the slides. Like I said, I think the question someone asked, what are the use cases and applications of machine learning pipelines? I think you'll see some of that in action. And then if that doesn't feel like quite an answer to you, maybe we can dive in a little bit deeper to what you're looking for, if that sounds good. And I'll share these links again when we get to the hands-on code portion. I shared the sign-up link. You'll also probably want this link. This is to GitHub. And I'm going to fill out the README a little bit more later. But right now, you'll see that open in Colab button. That's what we're going to be running today. And again, feel free to poke around there right now if you want. But I'll be getting to the code after some slides just to set up some concepts for everyone. And then also there's a Slack channel. If you want to join the Slack channel, maybe do an introduction there for more people to learn about you, but also to ask questions later. So if you kind of are interested in what you saw, then you're actually going to build a project later and have questions. It's going to be a great place to ask questions. And I'm in there, so also you can directly ping me if you have any questions about what you saw today, or really about ML and MLOps in general. There's quite a few people in that Slack group. I think it's over 3,700 or something like that, of mostly a lot of practitioners, so also learners. So feel free to post questions in there. All right, so this is an introduction to ML pipelines. And just a tiny bit about me. My name is Sage Elliott. I work at a company called Union AI. We build tools around making ML and data pipelines more robust and better. And again, we'll see some of that in action today. Most know Union from the open source called Flyte, Flyte. Again, I'll share a link to that a little bit later. But it's an open source orchestration platform that's incredibly popular. And then Union is kind of a managed version of that with some extra features. We're going to build a pipeline today, again, using Union serverless, but the main reason is it's easy for this workshop for you to get up and running without having to do a whole bunch of environment configurations. But what we see today, you'll be able to implement in the open source if you wanted to. And I'm streaming from Seattle. So again, I saw a lot more people join in. And so far, only one person has said hello in the chat. If some other people want to say hello in the chat and maybe just put where you're watching from, and if you want to include anything else about why you're learning more about ML pipelines, that'd be great too. Previously, I've worked a lot with computer vision, ML monitoring and evaluation, and then I have a background doing hardware, IoT, and then with the other stuff I mentioned, a lot of MLOps around it as well. Feel free to connect with me on LinkedIn. I'm pretty active on there. So if you do have any questions, that's a good place if you're not in the Slack channel. I also host a AI book club on LinkedIn right now. And I do a new book every month we read as a group, and then we meet almost weekly to discuss it. So also a really cool place if you're learning about machine learning right now. This month, we're reading a book called The Fundamentals of Data Engineering, which is kind of about building pipelines, but more from a data engineering perspective, which often ties into ML and MLOps as well. So check out that. Again, I'm in the Slack channel, and if you want to join there, say hello, ask questions later. That's a good place to do so. About you again, I saw one other person, or no, two other people post now. Awesome. Maybe post where you're watching from. I see quite a few people here, but not that many people in the chat yet. Definitely makes it way more fun for me, but I also think for other people watching, feel free to comment and say hello in the chat, but also ask questions as we go. But it's kind of cool to see other people, the other people that are watching, and maybe hear a little bit about their background. So feel free to share it in the chat or share it in the Slack later. A quick overview of what we're going to cover. So we're going to do some slides first, and then we'll actually go and build a workflow or a pipeline, really. And what this pipeline is going to do, one, we're going to create a container image. We'll talk on these a little bit more, but that allows us to create a reproducible environment where you can think of a container as kind of a little virtualized machine. And when we run stuff in there, that virtualized machine basically should be the same as it was before. So we can rerun workflows or models or whatever we want to do and expect the same results. And then we're going to build a pipeline. And our pipeline is going to download a data set. It's going to process that data and visualize it. So we kind of have an understanding of what our data looks like. we're going to train a machine learning model. Then we'll evaluate that machine learning model. And then we're going to save that model to the Hugging Face hub in this case. But this kind of demonstrates how to move a model out of your pipeline. So you could be like deploying it to SageMaker, but maybe saving it in something like a hub. It's a pretty common practice of a workflow. And then we're going to use the model. I have a typo there, not mode, the model for inference. And I'll show how to like pull it down from the hub, use it locally. But then also we'll talk about how we could use it from the API directly in our pipeline as well. And in our case, today our model is going to be kind of lightweight, but everything we learn can kind of scale to more complex models and pipelines. So for instance, using the model for inference in the pipeline might not make as much sense because we have a lightweight model today, but if we have something where we need a GPU, like a large language model, you could spin up a container and run workflows in there. So we'll see that in action and actually run through a notebook using Python. So again, concept overview, do a quick setup, build our workflow. And just want to mention too, depending on your background, this could feel fast-paced or challenging, and that's totally fine. Stick with it. No matter your background, if you have the Google account and the Union account, you should be able to run the workflow today, and I'll be explaining the code kind of as we go. Quick kind of intro on MLOps, or sometimes LLMOps. Now everyone's implementing large language models, and there's a lot of overlap. MLOps is the set of best practices and tools that aim to deploy, monitor, and maintain your machine learning models in production. And I really like to think of it making this more reliable and efficient for your company. So you might have seen, some steps like this before. And actually, if anyone in the chat wants to put in, have you ever deployed a machine learning model before, or maybe just trained a machine learning model? Put it in the chat. And so it's kind of fun to see kind of what people have done. And I see someone said they're also watching from Seattle. Awesome. Yep, I'm here in Seattle. I'm kind of excited actually for, I think it's supposed to start raining maybe next week. And yeah, I'm excited. Someone said they're watching from Hayward, California. Someone said they're watching from London Square, Oakland. Awesome. Welcome everyone. So again, maybe put in the chat if you've ever built something like this before. And this is kind of a representation of a bare minimum machine learning pipeline. And there's a lot more you can add to it. But typically you're going to want to be collecting data in some way. And then with that data, also you'll probably do some sort of munging or cleaning of that data. And then you're going to train a model with that data. Once the model's trained, you want to evaluate it, often on a holdout data set, to make sure it's going to be performing as well as you would hope. Then you'll put it in production. And then once it's in production, you don't just leave it there. Most of the time you want to monitor it in some way, and it really depends on what you're building of what that looks like. But you want to make sure that your model's performing as accurate as you would have hoped and not making any big mistakes that could cost a lot of money or harm to people. So you might monitor and then collect production data. And then basically you build this into a loop. So you're collecting data from production. You're probably retraining a model with that new data, and maybe you're using monitoring to understand when that should happen. So if data drift occurs where new data no longer looks like the training data set, maybe we want to take that segment of that new data, train a model, and then put it back in production and evaluate it and kind of build this little machine learning lifecycle loop that's pretty common to see. And then again, this is just bare minimum. There's a lot more that can happen. Like I had mentioned processing data. If you're building stuff with LMs, you might have vector databases, guardrails, and it's pretty common to do A/B deployments or shadow deployments as well. So once we train that new model after it's been in production, we might deploy it, have it running on production data, but maybe it's not the model actually making predictions for the end user yet. And we can evaluate those two models on production data and then select the best one over time. Putting this all together, you've probably seen some of these tools before. Again, feel free to put in the chat, like if you've used any of these before. It's kind of fun to hear about as well. So you have things like your data collection and extracting and transforming and validating that data. You have your training. You've probably used things like TensorFlow or PyTorch or scikit-learn. Today, we're going to use scikit-learn. You want to test that, basically use your test data set to evaluate your model, and then monitor in production, deploy it. These are some cool tools to look at if you haven't already, and then monitor it in production, and then do that kind of thing like we were saying, retrain and scale out. So at the core of building a pipeline with all these tools is often something called orchestration, or ML orchestration, or AI orchestration, or if you're just doing data pipelines, you might call it data orchestration. And it does depend on the kind of size of your pipeline if you need a whole kind of a tool or platform to do this. But adding them in, again, often make your pipelines more reliable and efficient for your AI applications. So some things to think about is this can add scalability. So the platform we're going to use today is built on top of Kubernetes. So it's easy to kind of scale out as you need more and more compute. You want reproducibility. So we talked about using container images. Basically, in this case, we're going to want all of those tasks of our pipeline to basically run in containers so they can be reproducible every time. And then we want versioning. You probably have experience maybe of versioning your code if you've done a lot of coding before, right? You've probably used GitHub. Well, often it's pretty important that you not only track your code, but also track the data that was used to train your model and the version of your model. Basically, all the artifacts generated in your pipeline. You want kind of a trail of those, so you could go back, look at a pipeline run, see exactly what happened, what every output looked like, and then run it again and get new versions of that code. But maybe you want to roll back and get the other specific versions. Some industries also are more stringent on having versioning built into your pipeline. So, like healthcare, for instance, might want to actually track all the data and code used to generate specific models. I think that I haven't actually had to gone through the process, but I think it's required for some of the FDA approval for some healthcare models. And then often I know finance industry is pretty strict about a lot of stuff like that too. Should add improved efficiency. So it should allow you as a data scientist or ML engineer or your team to really focus on the model development and development of code. And then also a huge thing I see when talking with people about implementing more modern MLOps or data ops practices is really optimizing your resource usage. And that could be resources like your compute, but also resources around your data scientists and people. And this leads to like a huge reduction of cost, often for developing your application. So I'm going to talk about just like a couple things to keep in mind when you're choosing an orchestration tool that I've seen a big impact on, not just the typical stuff that I would for sure want, like scalability, reproducibility, versioning. That's probably why you're picking an orchestration tool in the first place. But a few things that really stand out to me when I'm talking to people and they say this helped me save a lot of money is this might sound obvious, but not every tool is built for this, is optimizing for local and cloud development. So a lot of times you have a pretty powerful computer where you can train machine learning models on. Maybe not every LLM architecture because they're really big, but you might be able to take a more simplified LM architecture to kind of test out your whole pipeline or workflow locally. So you can utilize your local computing resources over just the expensive cloud ones. Also, sometimes running a cloud takes a little bit longer. So if you're just creating like a pipeline for the first time and you don't want to wait for your containers to spin up or cloud to spin up, you can quickly iterate and test locally. Again, I found this to be a pretty big time saver when developing a pipeline. I can get it working in some MVP state and then kick off a more complete job in a production cloud environment. I'm leveraging caching in the pipeline. So let's say we're going to train a machine learning model like we're going to see today. And we'll actually see this in action as well. Is we're going to use caching to basically like we want to rerun our whole pipeline maybe several times. In this example, we're hypothetically training a model and maybe we're changing hyperparameters on that model to get the best fit. And part of the pipeline, we're downloading data set. We're also doing pre-processing to the data set. But I want to rerun this whole workflow again with different parameters around my model, like hyperparameters on how it learns. So every time I rerun it, I don't want to download a data set or pre-process that data again. That could be a really big data set. Like if a big computer vision data set's there, that could take a long time to download. We don't want to do it each time. So we can just leverage caching. So we'll see how to enable this in the platform we're going to use today. But you'll just say, when I rerun this workflow, I want caching. And now these things shouldn't be ran again. And you'll just leverage the outputs that were saved in that state. Task level resource management and containerization. So you want to use precise resource attribution that ensures that only the compute that you really need to build your task is there or to run your task. So for example, if you were building a workflow and you're going to train a large language model or something on a GPU, or a whole bunch of GPUs, like maybe you're using 8 A100s, that's really expensive to have up probably the whole time. And maybe even if you have it locally, you might be preventing other people from training their models and kind of slowing up that queue of GPUs. So again, if we had a pipeline that looks something like this, we don't need a GPU to get the data or pre-process the data properly. We just need CPU compute for that. And then training a model, we want GPU. So in this case, we can specifically say what compute we want for every single task and only use that compute for every single task. So instead of running all of this on a GPU workflow, like some older MLOps or data architectures, you'd have like one single workflow you're running a whole pipeline on, or one compute cluster you're running a whole pipeline on. You can actually just define exactly the compute you want per task. And then inside that is also the containers that we talked about. So you could use a container only containing certain libraries, and then saying exactly what compute you want that to run on. So it makes it way more efficient, and again, can be a big cost reduction. So you're not paying for 8 A100s when you're downloading a data set for an hour. Another less obvious one I've seen that's pretty helpful and actually just saved me from causing an error today is strongly typing. So if you've done some sort of language that requires strongly typing, Flyte, the open source orchestration platform like we'll see today, requires your tasks, so every single part of your work, your pipeline, to be strongly typed, where you're defining the input data type and the output of that task. So if you kind of, when you're structuring and writing your code, you have to think about what does the data look like when it comes in? You know, is it a string? Is it a pandas data frame? What does it look like when it's coming out? Is it an integer? Is it also pandas data frame? Is it a model type? And that way, when you're writing the code and putting maybe different tasks together for different workflows, you kind of know what to look for or know how these tasks work. And then one thing I'll also just quickly mention that can be a really big cost saver is harnessing spot instances and or batch processing if it's available sometimes. So if you're okay when you're running your workflow or model prediction, so again, if you're using something like OpenAI and you're processing a whole bunch of documents, but you're okay if it's not like a real-time chatbot, you just want to get embeddings for a whole bunch of legal documents or something like that, and it's okay with you if it takes a couple hours. Think about looking for things like spot instances where AWS might have basically majorly discounted compute that you could use for your workflow, or something like OpenAI, which kind of does the same thing behind the scenes, where it doesn't get priority compute, but it'll still run, but it just might take a little bit longer, and usually it's a lot cheaper. So those are some things that I see a big benefit of people adopting more modern kind of orchestration frameworks. And today we'll be using something called Union Serverless. And if you just joined, I just mentioned Union's built on top of Flyte, which is open source. And what we're going to see today, you can do in the open source. We're using serverless again because it's way easier to set up, like for a workshop like this. Flyte has, again, it's not hard to set up locally, but there'd probably be enough issues if people were trying to do it in like 3 minutes before we start running. So we'll use Union today. And again, I think I shared, well, the links are in the description if you just joined, and I shared it in the chat, and I'll share it again here in a minute when we get to the code if you want to sign up. But with Flyte and Union, it gives us, we'll see how to define tasks and workflows. And the task is a segment in that workflow of like downloading the data, training a model. Every one of those inputs and outputs, like I mentioned, has to be strongly typed. Each task is also containerized and versioned. So every time we run a task or a workflow, we'll kind of get a snapshot of that version and all the artifacts generated out of it. And it gives us a declarative infrastructure. So again, we'll see this in action, but we can say in our task, we just say like the amount of compute that we want. Do we want GPUs? Do we want a specific type of GPU? So actually in serverless right now too, there's 3 different GPUs you can use. And I think off the bat, you get something like, I think you get $30 in credit for free. So if you do want to use an A100, there are A100s in there. And then there's L4s and T4s. So if you're looking for some free GPU time, it's kind of cool that you can use it in there as well. And then it's built-in versioning, caching, like we talked about, type safety. It's really flexible. So there's a rich plugin ecosystem, but also it should work probably for most of the machine learning libraries that you're looking for, I'm guessing, out of the box. And it's scalable, like I mentioned, built on top of Kubernetes. So if you need to scale up more compute, that makes it really easy to do so. And we'll also see in action today, it has a really nice user interface you can use to see your pipeline and rerun everything, but also there's a great Python API that, again, we'll be using the Python SDK to write our workflows and pipelines, but we'll also use an API to interact with models once they're trained. And just if you've never done machine learning before, a one slide introduction is, you basically have something like a function. Today, we're going to use scikit-learn, which is a library that makes this really easy. We're going to pass data in to that function, a specific machine learning model. It's going to learn patterns from that data. Then we could give it a new piece of data it's never seen before, and then we'll get a prediction return. And today we're going to use a pretty simple machine learning algorithm called k-nearest neighbors. Has anyone used this model before? Again, let me know in the chat. And a kind of simplified version of how this works is here's like a 2D visualization of our data, and we're going to be using the iris data set, which is kind of like the hello world of machine learning data sets, where you have these three classes, Virginica, Versicola, and Setosa. And the way k-nearest neighbors works is like, say this black dot is a new piece of data, and it's going to look for the k, in this case, would be the number 4. It's going to look at the 4 closest neighbors. And in this case, 3 of them are Versicola, and 1 is Virginica. So what do you think it would predict that new piece of data belongs to? A Versicola, right? Because more of these legs kind of belong to that class. And so it's always going to be looking for the 4 closest in this case. And the majority is going to win the vote of what class it belongs to. And then saving and versioning models, we're going to be using both Union/Flyte versions each run, like I had mentioned. So we can see that in action, but we'll also see how to move a model over to Hugging Face Hub and then download the model from there. So that could be really useful if you want to kind of download to like an edge device or something like that. This is kind of a workflow for that. And that's enough slides. So let's go ahead and run a workflow. So I'm going to post the link again, but again, they're in the description as well. And if you haven't signed up yet, go ahead and sign up here. Again, there's no card or anything required. I think you just get a verification email. You do need a GitHub account though. And like I'd mentioned at the beginning, if it's a new GitHub account, it might take a while to get approved. Since I think for that, we kind of have to manually go ahead and approve those and make sure that they're not bots right now. Once you open up the GitHub link, you can click this Open in Colab tab. And this is going to open up a notebook that was in that GitHub in something called Google Colab, which is basically Google's way of hosting a Jupyter notebook. And if you haven't used a Jupyter notebook before, it's a really cool place to run code, write documentation, and see visualizations kind of all in one place. And you can run this directly from here, but I always recommend the way I like to do it if I'm following along for a workshop is save a copy in my own drive. And that way I can make edits to the code. I can make edits to the text, and it'll stay in that state when I go back to it. And if you do break it, don't worry, you can always come back to this original link and make another copy. Or you can go back to the GitHub. And if you want to come back and run this locally later, here's the notebook for it. And there's also a workflow.py, which again, I'll talk about kind of how the workflows work here in a minute. Feel free to also star the repo and come back to it as well. So now I have my own copy of this intro to pipeline. Does anyone else have their own copy that wants to follow along? I'll take a pause here real quick. I know I went through a lot in the slides. Any questions on that? And then also, does anyone have this open and were they able to make their own copy? Once you do have your own copy, you can initialize the compute environment by hitting this little play button, or when a code cell is selected, you can hit Shift Enter. And so that's often what I do. So you probably won't see me hit the play button. Someone said they got the copy. Awesome. Thank you for letting me know. There might be a couple spots where I say, did this work for you? Great. All right. And then this next code cell will take a minute to run because we're going to install some Python libraries in our environment here. So not only is this just like a hosted Jupyter notebook, it's a whole little compute environment. So you can install Python packages. A whole bunch of them are already installed, actually. But we're going to install some here that weren't here. And again, this will take probably under a minute to install, but you'll see it loading. While that's happening, I'll quickly show you kind of what Union looks like or Flyte. And again, hit that sign up now if you haven't, and it might take a few minutes. And then once you're signed up, you can go to this serverless.union.ai. So once you get that kind of onboard email that said you're approved, you'll get something like this. Your dashboard will look empty here. You can see I have a whole bunch of runs in the last 24 hours. In the last year, I have even more. Red means it was a failed run. Purple, something I terminated. Green means successful. And I'll go look at what the workflow looks like that we're going to build today. You can see all these steps that we have: this download data set, process data, train model, evaluate model, model predict, and then upload model to Hugging Face. And I can go to this graph view, and this gives us the DAG, and it's really easy to see kind of the flow of data or artifacts between each task. So here we're downloading data set. Then that goes to this pre-processed data task. Then we train our model. From there, we output our model. And you can see that we also outputted a test data set here to this evaluate model task. And then from there, we upload that model to Hugging Face. And then we also have an extra step that you might not always want to do depending on your pipeline, but we have a really lightweight model today. So I'm building into our pipeline another run of our model where I can pass in new data. And this data might be well out of the bounds of the test data set or the training data set, but I might want to see how our model behaves with it. So sometimes I like to add kind of another little model run step and give it something that I really want to see how it worked just on that specific piece of data. And that's what we're going to be building here today in the Python SDK. And I can click on these and you'll have things like a viewable input and output for every task. You can rerun tasks, you can rerun workflows directly from the UI. In this one, we also save a pair plot of our data. So directly in the task, like we process a data set. In this case, we generate something called a pair plot, which gives us the two-dimensional view between all of our features in our data set, and then we save that here. And I really like to have something like this every time I bring in data. I like to have somewhere where I can visualize what that data looks like. So it might be me loading in data, might be me loading in data, doing some sort of processing on it, or just loading in data and a set of data annotations. So for example, computer vision, if you're loading in an object detection data set, you're going to load in images and then usually like a form of a JSON file or something with where those bounding boxes belong. And I always like to load them in and see what they look like visually. So I know kind of what my data looks like. And I also know that maybe I loaded in the data correctly. For example, if you're doing that computer vision one, there's been times where I've loaded in the images and then I messed up loading in the annotations. And so it drew the boxes in the wrong places. And I swore I loaded them in right. And then when I was training my model, it would never learn anything. And I was wondering why. And then I finally looked at my data. And so I learned my lesson of always load your data and visualize it just to make sure it loaded correctly. Also, if we don't have something like a data quality check, which you can totally add into a pipeline, it's good for you to maybe spot check and see, is this data, does it look like you're expecting it to be? And so you might be collecting data from production, like we talked about building out that lifecycle. And then you might want to go and visualize what that data looks like. And if it was way, you had some new data way out of bounds, then you can know, oh, my model probably won't work on that because it doesn't look like the training data set. But you can add in kind of automatic data quality checks for that too. But if you're not doing that, I always like to have some sort of way to kind of visually see my data. All right, so I'm going to go back to my copy and it's done installing all the libraries. Once that's done, and if your sign up for Union went through, you want to run this union create login, and it's going to authenticate this instance basically to your Union account. So it should generate this URL and says authenticating pending. I'm going to click on that. Don't change any of the numbers here. It'll have some letters and numbers, and then just hit next. And then it says device is activated. I can come back to my notebook, and it says authentication successful. And if this works for you, then hopefully the rest of the notebook should work here. And I think I also forgot to mention part of the workflow. It's okay if you don't have it. It'll just fail in the last node. We are going to upload the model to the Hugging Face hub. So you should also create a Hugging Face account. There'll be another opportunity to make this though, if you don't make it right now. But I forgot to share that as well. Hugging Face is a really cool company too, where they have things like hosted spaces where you can host machine learning models. And then they have something called a hub, which is where you can save like models and data sets too, kind of like GitHub, and then pull them down and access them. So we're going to use it for part of our workflow. But again, if you don't have that, that's actually fine. You'll just have a failure in one of the nodes, but you'll still run most of the workflow. It just won't upload the model to Hugging Face. So you should want to do it. But if you don't want to create that account right now for whatever reason, you can still run most of this workshop. And again, anyone watching, are you following along, and were you able to authenticate into Union? Pausing to see if there's quite a few people here. I hope some of you are following along. If not, oh, cool. Someone said they got authenticated. Again, appreciate the message in the chat. Really helps me know that it's working. Great. All right, so let's go ahead and build one of the simplest workflows that we can in this case, and then we'll build that more complex one. So this isn't something related to Flyte or Union. This is actually just part of a Jupyter notebook. You can use something called magic functions, I believe is what they're called. So we use this %, and then we said write file. And what this is going to do is all the code below this line is going to be written to a Python file called simple workflow.py in this case. So if we run this, we can actually open up this little file explorer and see that we have this workflow.py now. And if we wanted to change this code at all, you can change it in here, rerun the code cell, and it'll overwrite that Python file. Because Flyte and Union, they expect there to be Python files. It's not going to run directly from the notebook here. So here we're importing task and workflow from FlyteKit. FlyteKit is the Python SDK to interact with Flyte, or Union in this case. And then we're going to define a task. And you can see that a task and a workflow are just Python functions. So you get to write code kind of as you normally would, except for you're strongly typing them. So this is the input to that function name, and we're saying that it's expected to be a string, and the output is also expected to be a string. And in this function, we're just going to return hello, whatever that string is that's passed in. And then as the workflow, again, this is a super simple workflow. This workflow is just calling that one task, but the workflow is where you define the data flow and the flow of all your tasks and functions. And again, we'll see this a little bit more complex here in a second. But I ran that. And then if we run this next code cell, oops, syntax error. If that was in there, I don't know if that was in the notebook or if I accidentally hit that. Remove that pipe that was in there. So that's just a comment at top. And then we're just calling union run. And then we're calling that Python file that we just created. And then the workflow here is called main. So we're calling that. And then it expects a parameter here called name. And we're going to define it here. So we're saying Flyte, and then we get returned hello Flyte. And this is us running that workflow completely locally. Now, if we want to run it off into our compute cluster, and again, if you set up Flyte, the open source, you would be setting this up on your own like Kubernetes cluster. That could be on your own bare metal. That could be in something like AWS or GCP. And so we're hitting run. And in this case, it's going to run on serverless, which is our own hosted compute. But again, if you ran this on like on Flyte, it would just depend on how you set it up, where it's basically going to run. So in this case, it ran incredibly fast. Mine says already done. We could go to graph view and we see, our workflow is one task. We start, we say hello world, and then it ends. And if you click on that task, again, we get some information about it. We can look at live logs from here. We can look at what the inputs were. In this case, it was Flyte because that's what we passed in when we called it from the SDK. And then the output is that return string, hello Flyte. And then if we wanted to, we could rerun this single task, or we could rerun this whole workflow directly from the UI. We'll also see how we can rerun this from the Python API a little bit later. But it's cool. So you can build these workflows out that can take in different parameters, like different hyperparameters for machine learning models, different links to data sets, really anything you can think of, and relaunch them from a UI. So if you had like an organization built out and you wanted people have access to these workflows, they can basically just rerun them from the UI here or the Python API and pass in new parameters, which is awesome. So here you can type in something new. And in case you didn't see where I did that, I went up here and I'm hitting this relaunch button and I'll type in workshop. But it could be any string you want. I'll hit launch. This is going to kick off the whole workflow again. Now, again, it might take a little bit longer than than it did when we ran locally, because it's spinning up a whole container here and then running that task in. So it spun up this little container. And then again, we got the input workshop, and then the whole output was hello workshop. So this is a super simple workflow. Does this make sense to anyone? Basically, what we've done is at the decorator task and the decorator workflow, we'll see how to pass more declarative stuff into these decorators. But each one of those is now kind of creating, either a task of part of a whole workflow, which would be one of these individual things. And then the workflow is like this whole thing and how data flows between them and how in the order that they get called, which actually this is a better representation, right? A task is this, and the workflow is what this whole thing looks like. So if we go back to our notebook, we can get ready to run our more complex workflow now. But real quick too, if you kind of forget the parameters that you need to pass in to a specific workflow, you can call union run a simple workflow, main workflow in this case, and then pass in the flag help. And I'll say, name is required basically to run this workflow. And if you want to look at a whole bunch of different stuff you can do with workflows, you can look at this help tag. Some things to note is maybe project and domain real quick. So if I went back to my union dashboard and I click on this little union icon up here, you'll see that I have several projects. You might have these three, or you might just have the default and system. Default is by default where all the stuff we run is going to go, but you can actually specifically create little buckets to define where your workflows live. So obviously you're building a lot of projects in a big company. This will help you stay organized. And the domain is also in development, staging, or production. So today we're just going to keep everything in default, and it's going to be in development. And then when we build a image container, which you'll see here shortly, that'll run this little systems folder. So for me, you can see I built a new container last week. Yours will be empty right now, but soon it won't if you're following along. So let's go back, and now let's build the more complex workflow. We're going to create a container image. Has anyone used anything like Docker before or created container images? We're going to see a slightly different way to do it with a built-in thing in Flyte called image spec, which is really cool. So if you don't love writing Docker files, which I know I don't, there's a way to kind of do it directly in the Python SDK, which is really nice. So again, after that, then we'll download dataset and basically build up that whole DAG. And if you want to go the full process of uploading your model to a model store, sign up for a Hugging Face account as well. Again, it's also free. It should take like less than a minute to sign up, probably. I think you can even just authenticate with your Google account. And then one thing to note is if you're signing up for the first time with them, I think you'll get a verification email, and you'll want to click on that or verify your email so you can create a token. And I'll show how to do that real quick. So when we do that, we'll want an access token so we can save our model to our model hub. So if I look at my profile page, you'll see I have some repos down here. I have this ML repo, and here there's like a saved model in. This is what we're going to do today. So we're going to go to like your little icon up here, go to settings, and then go to access tokens, and then just create a new token here. Hit create token. You can give this any token name you want. I'll just call it workshop September 10th right now. And then we want write access so it can save a model to it. So click this one button and it'll automatically check this read one as well. And then scroll down and you'll have this create token. And once that's done, you'll get a token that looks like this. Just copy it and then run this next code cell. And I can go over that again if people want. Run this next code cell. And this is actually a text box here. At least in dark mode, it's hard to tell that it's a text box. But there is one there. Click on that, paste in that token, and then just hit enter. And for me, it threw an error. But the reason is because I already have that token with that same name. Basically, we're creating a variable called Hugging Face token that Union can reference and pull in the access token to save a model to your profile. And so if you went to settings in your Hugging Face account and you went to access tokens, and if this is grayed out, I think that usually means you need to verify your email before you can create an access token. And if you don't put in your secret there, it'll be okay. Just that last part of the pipeline will fail. And someone asked, where do you paste the token again? A great question. So in this code cell right here under machine learning workflow, hit shift enter or run on there. And then you'll see I'll say enter a secret value. And at least in dark mode, like I mentioned, it's hard to know that that's a text box, but it's right here. And then just paste in that token. And then once you paste it in, just hit enter. And it should work for you. For me, it's going to throw an error, again, because I already have a token with the same name. And if you ever want to delete a token, well, this is how you see them all. Get secret and list all the ones I have in here. These are the names. And you said, got it to work. Awesome. Again, thank you for letting me know in the chat. It makes me know that it's going smoothly. So great. If you want to delete the token, you can uncomment this, called union delete secret, and then pass in the secret name, and it will delete it. And then, all right, so we're going to go ahead and write our whole workflow here. What I would recommend doing, it shouldn't take that long to build your container image. I will walk through all this code here in a second, but what I do maybe recommend is, actually, it shouldn't take long at all on this one with just the scikit-learn. I've done another workshop where we have to build a container image with like PyTorch and other stuff that takes a little bit longer. So I think it's okay if I just walk through this. Similar before, we're using write file, the Jupyter thing, where it's actually going to create a Python file called workflow.py. And then I'll just walk through the whole workflow as we're building it. Feel free, again, if you want to scroll down and see how to run it, you can. There's just one section where if you don't change the variable to your Hugging Face account and repo name, it might throw an error. But again, that's okay. You can't really do anything to really break it. So feel free to go play around with the code cells underneath if you want. But I'll be walking through this code. So we import all the libraries we're going to use. I'll just kind of call these out, I think, as we go in the code. I'm also happy to come back and walk through anything specifically in here if you want to later. So I might go somewhat high level through here. But if you have any questions, let me know. So first thing is we're going to build that container image. We're going to use something called image spec that I kind of mentioned before, which is a built-in feature of Flyte, where instead of writing Docker files with all the parameters you want, you can actually define them in Python right here in your code, which is really neat. In this case, we're just going to pass in the libraries that we want installed and the specific version of them. There's a lot more you can do with image spec, though. Like you can have apt-get install other applications, or the specific CUDA number that you want in your environment. So for today, we're just passing in some Python libraries, but go look at image spec if you want to kind of see all the really cool features it can do. We have a function that is converting figures to HTML. So if we do want to save any files, like actually we're going to do that with the pair plot. It's going to generate an image. We're basically just want to change that image to a format that can be embedded directly into HTML. Then we're going to define our first task, which is download the data set. And instead of just having that task, we're going to start passing in some parameters here in the decorator. So we have cache is equal to true. This is us enabling caching, the thing that we talked about that we probably want in a lot of your pipelines. If you're doing things like downloading a data set and then training a model, but you might want to rerun this whole pipeline with different hyperparameters, you don't want to download the data set every time. So we're going to enable caching. Every time we run, it's not going to download it unless we specifically tell it to, or we change this caching version and we want a new data set. Then we have this parameter called container image, and this references the variable that we created up here with image spec. So for every task today, we're going to use the same image, but you could have different images and containers for every task if you wanted. And then we'll have this request resources, and we're just today looking at CPUs and gigabytes of memory. So for this task of downloading the dataset, we are passing in 2 CPUs and 2 gigabytes of memory. That's all we kind of really need for this task. But if you're doing a much more complex one, you can pass in way more CPUs, and you can pass in GPUs, like I mentioned too. So in serverless, and again, if you're using the open source or the hosted version of Flyte called Union that isn't serverless, you can kind of define what the max is for your cluster. So if you're using serverless, you'll see that like the max CPUs you can request is 48, and the max GPUs is 4. But again, that would depend on your cluster and setup for either Flyte or Union. And then we have our download dataset function. It's not getting any inputs, but it's expected to output a data frame. So we're downloading the iris dataset that's built into scikit-learn. And then we're just kind of combining the target variable to that. So we'll get a whole data frame that contains all the features and the targets. And we'll see what that looks like when we investigate that pair plot again. And then we have our task, which is process the data set. And a new thing here is we're enabling something called Flyte deck. That is that thing I showed you before. Let me go back and pull that up real quick. Oh, I'm in not my defaults. So if I went in here and I looked at the process dataset, Flyte deck enables this button here and allows you to embed information. And by default, it has some other things like you'll see the output here, which is 2 data frames. You'll see the input. You'll see the source code version, and you can pull these out again from by the API if you wanted to. But it's a way to kind of visualize it directly in your pipeline. And then metrics is the thing we're going to create today, which is embedding this pair plot directly in there. So it's a cool way of kind of giving more information about the task in a visual way. You can really write as much HTML as you want, so you can make really complex data embedded in each task run. So here we're taking in the single data frame that we downloaded. It's expected to be 2 data frames, and that's because we're using something called train test split from scikit-learn, which takes in a data frame in this case, and we're going to use 80% of the data for our training, 20% for our testing. We have a random state, so it's going to shuffle it. But if we ever need to come back to how it was shuffled, we can put in that seed and see the same result. And then we're going to use something called stratify, which is when we shuffle it, we're basically going to try to have an even number of each class for our test and training data sets. Otherwise, you could shuffle and potentially be really biased, and like all the classes could end up, all of one class could end up in that 20%, and your model wouldn't learn from them. So you're trying to shuffle in a way that gives a good distribution of all the different classes. And then we're creating our pair plot with scikit-learn. It's going to change the hue on target. And again, we'll see that. That's the thing I just brought up, but we'll see this again. And then we're inserting a deck into the Flyte deck called metrics, but you could call this whatever you wanted, like pair plot or analysis or something like that. And then we're converting that pair plot to an HTML embeddable image. And then we're going to return the 2 data frames out of here. And then we have our train model function. Again, this might be relatively simple depending on what you've done before, like training models and building pipelines, but it kind of expands to more complex ones. Like you could use LMs or PyTorch models and kind of effectively build a pipeline like this, but you just might need more compute resources. For this, our container image, again, is the same. We're going to up the resources for training our model. It's a pretty lightweight model, so we really don't need much today. But we're just going to put 3 CPUs and 3 gigabytes of memory, so a little bit more than we did for our other tasks. And we're going to call train our model. It's expecting a data frame and then an integer, which is the number of neighbors. So remember when we saw kind of how this machine learning model works, that is this hyperparameter. So we're going to pass in 3 by default, but you feel free to experiment putting really high numbers or low numbers and see what happens here. So we're going to put in 3. It's going to be looking at the 3 closest neighbors and then make a prediction based on that. And then we're initializing our model, which is this k neighbors classifier from scikit-learn. And then we're just calling model.fit. So we pass in the training data and the training variable, or sorry, training classes. That these are the training features and these are the training classes. So it can learn patterns from this and then match them and basically learn what patterns make up those targets or classes that we're trying to predict. And this is a common annotation where you have X means those features. So in this case, it's the sepal, petal length and width. And then the Y train is like that setosa versicola kind of class that we're trying to predict. Then we have our evaluate function or task. We're enabling a deck here as well. Same image. We're just using the normal amount of CPU and memory that we did before. We have evaluate model. It's expecting a model, a data set in the pandas data frame format, and then it's going to output a model from there. And current context is something you can set in Flyte, where this now kind of gives you all the information available inside that container. So if you wanted to look at like what files are saved there or save a file to it, you can do so with that. In this case, we're using it to enable deck or really the order of decks that we want. Here we're evaluating the model on the holdout data set, which is X test in this case, and then we're generating a figure, which is a confusion matrix, which again we'll see here in a minute. If you don't know what that is, don't worry. And then it's going to be under the deck called metrics. And then this is us generating the whole report in HTML. We're basically just putting in the report that we generated here and appending an image. Again, you can get really fancy with the HTML and build some really cool stuff to look at. In this case, I don't think I pulled this one up yet. If we went to evaluate model inside the Flyte deck, we have this confusion matrix, which is kind of a cool way to see the predictions for each class. And then you can see how biased it is. And if it's making the wrong prediction, you know, which one is it doing that on? In this case, our model is actually perfect here. It made all the correct predictions and the classification report. It's 100% right in all the different metrics. And then we have our upload to Hugging Face, our second to last task here in this workflow. Again, we're just defining a small amount of CPUs and memories. One new thing here is we're passing in our Hugging Face token secret. So you need to pass in a secret that you want to use in every task. This is that one that we created with the Hugging Face. And then where it's expecting the model that we just trained, a repo name, which is where we want to save it, and a model name. So this would be the name of the model. So you could have this versioned or whatever you want. I'm just going to call it model today, model.pickle, which is an extension. That's going to be a string that we pass in. And then here this actually does check for a local environment variable called Hugging Face token. And if that doesn't exist, so you could run this workflow locally if you wanted. But if that doesn't exist, then when we kick it off remotely, it's going to look for Hugging Face token secret that we just passed in there. And then we're going to initialize the Hugging Face API, and we're going to create a repo. So it's going to take in repo name, the token, and then we have this flag that is exists OK equal true. So every time we run this, if that repo already exists, that's great, and it's going to rewrite files in there. You could turn this off if you want to have a warning. If it doesn't already exist, then it's going to create that repo. And then we're using joblib, which is a library to save a model. And we're saving the model, and we pass in that model name. And then this is the part where the upload actually happens. We use the Hugging Face API. We pass in the path of the actual file. So that's like where it's saved at in the container. And then the path in the repo. In this case, we're going to have it be the same model name, but you could put different names for each of these. The repo name. Again, we'll see how to pass that on in a second. And then a commit message, which for us is just going to say upload model. And then we have repo type, which we have is none. Hugging Face has a couple different types of repos, so you can have specific ones for data sets. Today, we're just going to upload a model file, so you don't need to specify anyone. And then pass in that Hugging Face token. And then the last task here is that separate task I mentioned. I like to kind of add in sometimes to do another prediction task. And we'll actually see we can kind of easily rerun that in the UI or in the Python API. So you have this trained model. You saw how it did in your evaluation or test data set. And now maybe you want to poke around at it a little bit more and see how it does with other data that it's never seen before or is like out of scope of your training data set. You can do that in this task. So we are enabling a deck again. And same image, same resources. We're just taking in that model, and then we're going to take in some new prediction data, and that's going to be a list of floats. And then we'll just get the predictions basically. Again, we'll see what that looks like. And then here is the workflow. So we have a little bit more of a complex workflow this time, where basically we're calling all those tasks here as functions and defining the flow of data and how those tasks get called. So we have that download data, process data, train model, evaluate model, model predict, and then we're going to upload the model. And then from that whole workflow, we are going to return the model. So there's going to be an output from this workflow that we can go look at, and then actually be the URI of where that model lives in the cloud. So if I run this, it wrote workflow.py. Remember, I can always run this help function or help flag to remind me what I need to pass in to run this workflow. And it says required is a repo name, required is a model name. Optional, I could also pass in number of neighbors. And I'm going to run this down here. But before I do that, if you created your Hugging Face account, put in your Hugging Face name here, username. So mine is Sage Codes. And then give it a repo ID. It doesn't matter what this is, because if it doesn't exist, it'll create a new one. If it already exists, it'll overwrite a file in there if there's a new file. So I'm going to call mine ML repo. You could call it whatever you want. And then this is already in here, but for the model name, we're going to pass in model.pickle. And a pickle is a specific extension that you can save models as. So go ahead and run that. And you should get this URL here. Actually, for you, because it's the first time running it, instead of saying skipping build, it'll probably say, build not found, building now, and it'll generate a URL that will take you to the system folder, and you'll see a task of building a image. And in my case, that's already done. So it says skipping build, and then it links me here. And I can basically watch my pipeline run in real time. We have download dataset. It's now processing the data. As those finish, I can click on to them and look at the inputs and outputs like we saw before, and look at my Flyte deck, see did the data look like I was expecting. I really like pair plots. It's a cool way. I don't know if you've seen this before. It's a cool way of looking at your data again in all the different dimensions, all the different 2D dimensions. So for the iris data set, if you haven't seen it before, basically I have 4 features. That's what the model is going to learn from and make predictions on. In this case, sepal length and petal length and width. And a sepal is kind of like an underbelly petal of a flower. And then you can see how they're all clustered. And then you can make some assumptions, like just looking at this little bell curve plot kind of tells you how separate a lot of these features are. So even just looking at this, I could make assumptions that these last 2 features, petal length and petal width, are probably going to be the most important features of our data set of making predictions because there's less overlap here. So to look at these and probably determine the closest, like the new data, it's easier to cluster them on the petal width and length. Someone asked, what should I call the model name? You can call it whatever you want. In my case, and by default, it should already be there. I'm just calling it model.pickle. I think you will want the pickle extension, the .pickle extension, so it can save and reopen. And training model. Again, this whole pipeline shouldn't take too long to run. And each time it runs a task here, remember it's spinning up a little container, and then running that task in there. So go to train model. I can see the input was this data set file that was a Parquet format. Also, something I didn't mention. So because these are all containerized, the data passing between each of them gets like serialized and deserialized. And Flyte kind of does a lot of that for you out of the box. You don't really have to even think about it. Just pass the data frame through. And by default, it kind of knows what format to save it to make it more efficient and reliable. So our model is trained. We have our evaluate model. You can look at the Flyte deck, see those metrics here for our classification report. I can also see the output again. And I think my whole pipeline's done here. So it ran this upload model to Hugging Face. So if I went to my Hugging Face hub, go to my profile, scroll down, and here's my ML repo. And you'll actually notice it says it was 21 days ago the last time I uploaded a file. The reason is because this .pickle file, I trained it with the exact same parameters and same data set, so it's actually the same looking file. And Hugging Face, if none of the files were actually changed, it'll skip uploading. So if I do rerun this, actually we could do this right now. Well, I won't rerun the whole pipeline right now, but I could go back in here and in this case, I'm going to look at model predict. And well, I guess I could rerun the whole pipeline. I got off my flow, but I could rerun this whole pipeline by having the let's say the k numbers of neighbors. It's going to be 6 now. You can see all these other parameters are the same. ML repo, test data, model file, and I'll hit launch. And now it's going to rerun that whole pipeline, except for it's going to be looking, it's going to be training the model with 6 nearest neighbors instead of 3. And then we did have caching enabled. I think there's a slight bug right now just on, let me see real quick if this does it or not. Yeah, it's downloading the data set again. I think we had caching enabled. If you use the open source or the regular version of Union, not serverless, this totally works, where we ran the pipeline and it didn't download or wouldn't have downloaded the data set again. I think this is a slight bug on serverless. If I didn't mention before too, the serverless is in beta right now, which I think I had on a slide. So there might be some occasional small little bugs like that. If you see them, let us know. But now we'll have a new version of a model with different hyperparameters, and then it should actually upload to Hugging Face. But if I go back to my previous execution here, and we have this model predict where we can just pass in new data, I can rerun just this task right from the UI. So I'm going to hit rerun, and we can pass in an array here. What should I pass in to see how our model behaves? Maybe some ridiculous numbers that fall out of range. If I went, let's all do really high numbers. So I went 1,000 or 10,000, 300s, 800s, or sorry, 8,000s. Really high numbers for all of our data. What do you think is going to happen here? And I could add another array really quickly in the UI too. So I'm going to hit launch. And again, this will take a minute. And what's cool is this is pretty commonly used for batch processing, actually. And again, our model today is pretty lightweight. But if you have GPUs available in your whole pipeline here, or you might have something more complex than just running predictions directly on a model. You might want to rerun like a processing data and then run inference on a model. You can use Union or Flyte for batch predictions here. So just keep in mind right now, if you're using it for that, you have to spin up a container. So the latency, there'll be a little bit of that while your container spins up. But it's a pretty common use case where if you're running some sort of batch prediction and you don't need those real-time results, or like a hosted endpoint where you get something in milliseconds back, you can host whole batch predictions here on GPUs and only spin up that compute when you need it, which is pretty neat. But here we just ran a workflow, machine learning, a simple, not even workflow, a task for our machine learning model with new data. These are all the really high numbers that we just passed in. And it still returned a prediction. The prediction was 2, which I believe is this Virginica class. And the reason why it still returned a prediction is we don't have any guardrails or data quality things in our pipeline right now. And so even though our numbers are way out of scope of anything the training data had, or that the model had seen before from the training data, it's still just looking at the closest 3 nearest neighbors in that case. The closest ones are still Virginica, even though they're way down here. So something to think about too when you're building your pipelines and inferences, you might want to have little data quality checks to make sure that the data falls within the realm you are thinking it might. Or if you get data that looks way different than the training data set, you might want to call some sort of error or alert so you can go investigate what's happening there. And so you built a whole pipeline, really, kind of with state-of-the-art tools and having things like versioning, caching all in there. Just a tiny bit more in the notebook if you want to follow along for this part is if you uploaded your model to the Hugging Face hub, here's how to quickly download it and interact with it. So I'm going to put in my username again and the repo ID. Should be the same thing that you did when you called it up here. So again, mine is ML repo. And I'm importing from Hugging Face Hub, HF Hub download, and joblib, again, the library that we used to save our ML model before. Oh, and yours might have thrown an error. You would actually want to put your Hugging Face token here. Or in my case, it didn't throw an error because we're doing this locally. And in Colab, you can actually have secrets saved in here as well. And I forgot. I already had mine in here. So yours might have thrown an error. If so, you would want to get your token pasted in there again. Or create a secret like I did. Now we add our downloaded model. You can see it's a k nearest neighbor classifier. In this case, it is 6 now because my other workflow was done running. And I think if I went and looked at my Hugging Face space again, you can even see my new model was uploaded because it looked different than the old model. And then we can interact with it right here locally on our instance, or this could be on a Raspberry Pi or on your own machine, a computer. It doesn't have to be in the notebook. And then we could get predictions back. So you can pass in whatever data you want in here, get predictions back. I'm going to go through one other way to interact with the model. And again, this would be really useful if you are running a more substantial model where you need more compute. And you can actually run this directly back in Union or on Flyte with the remote API. So all the things that we just did through our interface, like navigating all the executions, looking at all the tasks and all their outputs, you can do that directly from the Python API with the remote function. So here we'll initialize remote. And if you're doing this on Flyte versus Union, it's called Flyte remote versus Union remote. And then we're going to look at all the recent executions. We'll look at the first 100, but you could change this number. I think by default, it actually might be 100, but you could change this to lower or higher amounts. And we're going to loop through each of those executions. And then we're going to grab them if their name is equal to workflow.main, because that's the name of the workflow that we want to grab in this case. So if I did look at my execution log here visually, we can see workflow.main. These are the whole pipelines that we just ran. So you would change this to be whatever the name is of the workflow. So I'm going to run that, and then I can look at my execution list. I have several because I've ran this workflow several times. I think yours will probably just have one unless you reran the whole workflow. And then we're going to get the latest one in this case. So we're just grabbing the first one here by index 0. And then we get this little version hash. And like I'd mentioned, every time you run a workflow, it's versioned. If you were to click into any of these, this is the latest one. So we can actually see that hash matches that. And you can see this is the one I reran, but you can actually see the original workflow that is related to just by clicking in that. And then so let's grab that execution, that specific one, and we can look at the outputs. In our case, we have the URI of where that model lives. And we're going to grab that with this remote source. So this actually doesn't just give us what it was, which is actually gives us the whole path of where that model file lives. And then we're going to get the predict model task, that one that we just reran to get predictions. We got that task, and then we're going to pass in new inputs to it, which is going to be that Flyte file and the new prediction data. Again, feel free to mess around with these numbers, see what happens to your model when you give it really crazy numbers. And then we're going to call execute on that execution, where we pass in the inputs and that specific task that we want. And then it'll generate a URL here that we can go click on. And we can see that just like before, we have this task running. There's also another way where you can add in this wait true parameter, and it'll just run in here in the code cell until it's done running and then return the outputs. We'll actually see that here in a second. But for now, wait for this to be done running. And while this is going, what do people think so far? Is this your first time building like a machine learning pipeline? If you've built pipelines before, does this tool seem interesting? Does it have features that you never saw? Does it seem valuable? Is it something you want to play around more with, like personal projects or with a work project? Let me know in the chat. So we saw that was done, and I can now just resync that execution. And we have to resync it because otherwise it wouldn't have had the outputs there. And now we can get that first output from our workflow. or from our task and see the prediction was 0. So again, you can pass in new data, get different predictions, but now basically we're interacting with that model hosted um, in Union serverless in this case. Again, our model's really lightweight here, so you might not really want to do this unless you need this compute or you couldn't run that model. But again, it's pretty common. You're going to have something like a PyTorch model and you need a GPU. And again, you might be okay with waiting for the latency to spin up a container. Also, just I'll quickly note that we're working on new features to drastically like reduce the container spin up or having them already up, so you can actually have hosted models here. And it will actually be a good place for probably most serving use cases. Also, I'll come back to this code cell in a second, but in this way, we're kind of just treating the way that this API works by default, like in Flyte, is you treat data flow as kind of returns from functions. But there's a feature built into Union called artifacts. Oops, that's the. Are you sure you want to open link? There's a kind of a cleaner way to do this in Union with artifacts, so you can actually just have basically a variable with versions pointed to models or data sets and then call that directly in, versus getting like, this was our last execution and then I want to get the outputs from it, which is totally fine and it works. But if you want a even more cleaner way, you can use artifacts, which also gives you lineage too. So you don't have this because you didn't run this before, but you can actually generate an artifact and then kind of see where it's being used in what task and kind of what has happened to it. So a cool way to give you more insights to the artifacts, where they're being used and what happened to them, and then also easier way of pulling in like data and artifacts like models and data into your workflow or API here, or sorry, API calls here. So putting this all together, just kind of a little bit cleaner way versus calling everything individually. I just have two functions. I'm getting the latest execution, and then I want to make a prediction. And then here I would just call this make prediction function and then pass in new data and get something returned. So basically built a whole little machine learning app now that you could take this and wrap it in like a Gradio. Gradio is a library by Hugging Face, or Streamlit is another one where you can create user interfaces really easily for like machine learning projects. You basically take this, wrap it around Gradio and Streamlit, host this on their site even, and then have a machine learning app that'll call the Union API and make predictions. Some other things to keep in mind. So if you were making this for production, you also might want to make inference a separate workflow. So in this case, we're just calling the execution that was part of our main workflow here, this model predict one. And that works fine for a use case. But you might want to add to this later, like instead of just calling the model, like you want to do pre-processing or maybe call multiple models and then do a prediction based on that. You might want to actually make this a separate workflow called like inference or something like that, and then pass data in to the inference workflow. And then you can more easily build upon it, which is really nice. So again, that way is also good for batch inference. And then we're working on new features, so stay tuned soon to see more inference stuff coming to Union. So again, in the chat, it's been a little quiet, even though I've seen quite a few people are streaming. What did you think? Were you able to follow along? I know I went through stuff pretty fast too. So if you have any questions, let me know. Otherwise, that's kind of all the planned material I have, though, for you today. But you went through, you trained a machine learning model, you built a kind of state-of-the-art pipeline, and maybe you learned some stuff about pipelines that you didn't know before, kind of what to look for when you're choosing some of the tools. Yeah, how to think about them a little bit. So again, this could have been your first one. Might have seemed like a lot. Hopefully you found it interesting, and maybe it makes you want to dive a little deeper into building pipelines for your ML applications. And I'm going to pause and get a drink of water, but I'm going to wait and see if anyone has any questions or comments in the chat section as well. So again, if you have just like, was this interesting? Did you learn something new? Could you see yourself implementing an ML pipeline now if you've never done it before? Did it seem less hard than you thought it might be? Did it seem harder than you thought it would be? I see people are hanging around, but no questions. Oh, if you're interested in if you're interested in joining another event, might be some similarities, um, but it's going to be on computer vision and around building pipelines for object detection. Also, if you've never done a built an object detection model before, this should be a fun one too. Someone said, still waiting for union account approval. Yeah, sorry about that. I know there was a change in how they get approved due to, I think, bots and stuff. So hopefully we'll have that worked out. And I apologize that you weren't able to sign up immediately for this. And that might be that your GitHub is too new. But if your GitHub isn't new, let me know and I'll look into why that's the case. And also, we can probably manually approve you if you ping me on LinkedIn or the Slack channel. I can probably get you approved if you wanted to follow along later. Someone said, does it support deep seed? Remind me, what is deep seed again? Is that a vector database or am I thinking of something else? Deep learning optimization library. I haven't built something with deep seed in here yet. I don't see any reason why it shouldn't. Let me try to take a quick look though and see. Are you currently building something with DeepSeed? Because if not, too, let me know. I think it probably does, but I'd have to double check. I guess for sure it should, unless there's like weird outputs that maybe DeepSeed has. Um, and if it doesn't, let us know in the Slack. Again, it's a big open source community in there too. It's not just people at Union. Um, let us know if it doesn't, because we can build probably a plugin for it. Or it's something you can do, hopefully, with minimal effort. I'm bringing up DeepSeed and taking a quick look at it. Yeah, I'll have to double check. I'm not sure if I wouldn't be surprised if someone already uses it on there, since there's so many users, and especially in the open source. But I would just have to double check, I guess, before I say yes, 100% sure. But I'm imagining probably. But again, we'll see, because you can build a container, and if this is, yeah, I don't know. I'll have to take a look at it instead of, I guess, trying to figure it out right here. I'll make a note too to try to find out if someone else is already using it with DeepSeed. Someone said, great workflow. Got to see and follow along creating and training a machine learning model. Yeah, awesome. And not only did you just create and train a machine learning model, again, you did this in kind of a really modern MLOps architecture, really. Like, there's different parts you could tie into this pipeline, but you built a really robust pipeline, even if it felt really easy. This is built on top of Kubernetes. You can scale out your compute here. Everything is versioned. So if you want to roll back to different versions or trace, what was generated in the last time you ran the workflow, you can do so. You also saw how to save your model to Hugging Face Hub if you created the Hugging Face account. So you also have another place where you can like version models. You also logged the data set every time and the evaluation every time. So again, you kind of have full traceability for every time you run this workflow. And if it was your first time doing machine learning, you did train a machine learning model too, which is pretty cool. And maybe that felt harder or easier than you thought as well. It's always kind of fun to hear about people thinking maybe training an ML model is hard. And I'm not saying the field is incredibly easy or anything, but there's so many cool libraries that make it way easier maybe than you were thinking about building a machine learning model, or in this case, building a pipeline. Like some people might think to build a whole ops infrastructure like this, you might need a pretty big like ops team or someone to maintain it. And we just saw that not necessarily if you have the right tools for it. And something you can think about when you're basically planning the architecture of your MLOps or data ops is think about your team size and capabilities. And that comes into play of like choosing right tools or build versus buy. Like, do you want to set up if you liked what you saw today and you could set up the Flyte infrastructure or the Flyte platform on your own infrastructure. If you have a really small team, check out union.ai. We have the managed version of Flyte, but it can still be on your own like cloud compute. Or then now we have serverless as well. Again, this is in beta, but we have serverless where you can, just pay for the compute you're using through us. But yeah, check out Union AI and everything we're doing there as well if you want to see more of what we're working on and more features, including case studies of like Union and Flyte as well. Also, I think I shared the link earlier, but if you want to check out just the open source too, go to Flyte on GitHub. And if you have any questions, join the Slack channel and ask them there and become part of the community. With that, if there are no other questions, I'll probably wrap up the stream, but I still see people hanging around. So hang around a little bit longer, maybe another minute or two, to see if any questions roll in. Cool. I don't see any other questions. So again, I guess I'll share the Slack link one more time too. If you do have any questions, join that and you can message me later or put it in. There's a channel called Ask the Community. So if you have any questions about Flyte specifically, put it there. There's also a ML and MLOps channel too. Say hello or ask questions there. Andrew said, signing off. Awesome. Yep. Great to see you again. And I will talk to you all later.